Okay, in case you were wondering how do we get this correlation coefficient R, and how do we get this least squares regression equation y hat, well, there are formulas for it. First thing you need to do though is you need to find the mean of your x's and the mean of your y's. And actually the regression equation always goes through the mean of the x's and the mean of the y's. So in this case, if I calculate the mean of the hours from these 5 people, the mean hours was 2.4 hours, and the mean GPA is 2.9. And I also need to calculate the standard deviation for the hours on Twitter and the standard deviation of GPA. So if I calculate those, I get 2.0736 standard deviation for X, 0.8944 standard deviation for Y. And again, software can actually calculate this for you. So why do we need these two things? As I said, the regression line goes through the mean. This goes through this point. So the regression line always goes through this point. The mean of X's, mean of Y's. But also, we need this to calculate the correlation coefficient R. And it's a complicated procedure, but one of the formulas for R is the sum of the z-scores for X's times the z-scores for Y divided by the number of data you have minus 1. So the bottom of this equation would be 4. At the top, we have to find the z-score. What is the z-score? You might remember the z-score is a value minus the mean over the standard deviation. So the value minus the mean over the standard deviation. A z-score is the distance of each value from its mean in terms of standard deviations. So that's a z-score. So in other words, if you wanted a z-score for this value of 5, you would take 5, you would subtract off the mean of 2.4, and then you would divide by the standard deviation of 2.0736. So you have to do this calculation for each one of these numbers for the x's, and then for each one of these numbers for the y's. Okay, that's the first step. So if we do that, I'll do that quickly. If we do that quickly, we end up with these z-scores here. So like, for example, 5 is 1.25 standard deviations above its mean of 2.4, and this value 2.0 in the GPA is negative 1.01 standard deviations below. So it's 1.01 standard deviations below its mean of 2.9. So we do this for all of our values. We have a z-score. And then this here says you multiply them. So we would have to multiply each of these and get results and then sum that up. So if we do that, we end up with these products here, and then they all sum to, so we add them all up here, and they sum to negative 3.9361. That's the top part of that equation. That's the sum of zx times zy. And then what do we have to do? We divide by n minus 1. So remember, this is the equation up here, correlation coefficient. Divide by n minus 1. N minus 1 in this case is 4. And so when you divide this by 4, you end up with the correlation of negative 0.984. So that's our correlation coefficient of negative 0.984. So that's what we got before using the software. And now, once you get this number, you can use this now to generate regression equation. So let's look at that. So the regression equation we call y hat is equal to b1x plus b0. So b1 and b0, what are these things? b1 is the slope of the regression equation, and it's equal to the correlation coefficient times the standard deviation of y divided by the standard deviation of x. So we can calculate that out as r. We got r as negative 0.984 times 0.8944 divided by 2.0736. And if we calculate this out, we get negative 0.42 approximately. So that's b1. That's our slope. That's the slope we saw that as for more hours you spend on Twitter, for every hour extra, your GPA would drop by 0.42 if that relationship were true. Okay, now, so that's B1. B0 now is the y-intercept. And B0, now here's where the mean of the x's and y involved. B0 is the mean of y's minus B1 times the mean of x's. Now, B1, I had dropped some decimal points. I'm going to put in some extra decimal points that should have been there. It's actually negative 0.4244. So when we want to calculate B0, we're going to go B0 is equal to the mean of y, 2.9, minus B1, negative 0.4244, times x bar, the mean of y is 2.4. So you do that calculation, you're going to have 2.9 actually plus something, and this ends up to be 3.92. So that is our y-intercept. So if you recall, the equation was b1x negative 0.42x plus 3.92. So that's how you calculate the regression equation. And like I said, software can do this for you, but it's good practice to actually do this for a little set of data to see that you understand where these numbers come from. Thank you.